Okay, we're going to practice more of this problem solving with 2 units, and I'm going to introduce what to do if there are 3 units. Okay, City Park is opening a swimming pool. You can pay a daily entrance fee of $3 per day or purchase a summer seasonal membership for $82 and pay $1 per day to swim. How many days would you have to swim to make the membership worthwhile? Okay, so we're finding the number of days. So we have 2 units, we have days and money. Okay, so days. Days is going to be the X unit because that's your time, and money is going to be the Y unit. Okay, and then per, and the Y unit on top and the X unit on bottom, so dollars per day. Okay, so the dollars per day, well, we have $3 per day. But then you can also be a non-member and pay $1 per day. So 3/1. Remember, don't add them because you're either going to be a member or you're not. Okay. Okay, so since there's 2 different rates of change, we're going to need 2 lines. So I've got my beginning point, xy, plus mxy, x comma y, plus mxy. Okay, so we know what my m values are. $3 per day for this one, and 1 for the other. Okay, so prior to paying $3 per day, how much did I have to pay? Well, there is nothing, okay? So that starts at 0. Prior to paying $1 per day, 82, okay? Okay, so again, we want to know when these are equal. So he didn't pay anything, so I'm not going to put 0. I'm just going to put the 3x equals. And then he paid 82. Don't put equals y. I mean, if it was just one line, that would be the equation. But we want to know when it's equal to this one. So 82 plus 1x. All right, so we have multiple terms of x. They're on opposite sides, so let's balance out the smaller terms. So minus 1x, minus 1x. That gives me 2x equals 82. So I divide by 2, and 82 divided by 2 is 41. Okay, so 41 days to make that worthwhile. Okay, next problem. Alex has $5,000 in a bank account that's used for paying rent on his apartment. Every month, that means per month, there's an automatic withdrawal of $550. Remember, every and each mean per as well. Those are synonyms with per. Alex needs to put more money into his account when the account's down to $1,000. After how many months should he wait before refilling his account? So we're finding the number of months. Okay, so my 2 units are what? Well, months and money. So the time unit's going to be the x, and then that's going to be y. So per dollars per month. Remember, every and each mean per month. Okay. So every month there's an automatic withdrawal of $550. Okay. Now on this one, again, that would be negative because money's coming out of the account. It's not being added. So from the beginning, it's actually going down. So negative. Okay, so line. Okay, so I know my m is negative 550. And prior to that action taking 550 out of the account, we had $5,000. Okay, so 5,000. Okay, so I didn't have to do much. I have my equation ready to write. I have 5,000. And then we can, since it's negative, you can write plus negative, or you can just put minus 550x. Okay, so I like to do the plus negative, but that's just me. And that equals y. Okay, now we need to replace the $1,000 as my replacement value. Again, that's usually the last number in the problem. Okay, and that's money, so it's going in for y. Okay, so just take that y out, put $1,000 where it's at. So I got 5,000 plus negative 550x equals 1,000. All right, so here's my x. That's the only one I have with negative 550 as a coefficient. So we have 5,000 to undo by subtracting. Okay, and 1,000 minus 5,000 is negative 4,000. So negative 550x equals negative 4,000. And then it's dividing time. Divide by negative 550, divide by negative 550, and we should be good. Okay, I got 7.2, so it's going to be 7, okay? When it's going down like that, you want to always round down, even though, yeah, to the nearest integer. Okay, I'm gonna come back to number 3 later. Let's go do number 4. Okay. A motorist is stranded out in the middle of nowhere and lights an emergency flare. After burning for 3 minutes, the flare is 30.5 inches. After burning for 6 months, the flare is 29 inches. Given that the flare burns at a constant rate each minute, not money, I don't know why I would put that, each minute, how many minutes will it take before the flare runs out? That means IE is 0 inches in length. 0 inches is the replacement value. Okay, the key thing is at constant rate. It's burning the same amount every minute. Okay, they just probably don't tell us. Okay, so the units are minutes and inches. Which one of those is a time, a measurement of time? Minutes. So that needs to be x, and then the other unit would be my y. So per. Okay, I want to put inches on top because that's your y unit, and then per minute on bottom. Okay, now do we know the inches per minute? No, I don't think you do. Okay. It says it burns at a constant rate, so I know there's got to be an inches per minute to the problem. And how would I figure that out? Oh yeah, y minus y, x minus x. Okay, now the y is the inches, so what do you have for inches? Well, you have 30.5, and then it goes down to 29, so I take 30.5 minus 29. And then how many minutes are with 30.5? Well, 3. And with 29, we have 6. Okay, so 30.5 minus 29 is 1.5. And then 3 minus 6 is negative 3. Now you need to divide 1.5 by negative 3. And that's negative 0.5. So it's burning at a ½ inch every minute. Okay, it's going down. Okay. All right, now that I figured that out, I can make my graphic representation with my line. Okay, so I know I have my m value of negative 0.5. And question, did I even have the 0.5 in the original problem? No, I didn't. So that means I don't know where it started. What do I do when I don't know where the line would have started at before the rate of change went into effect? Oh yeah, y equals m dot x plus b. With a combo. Okay, remember the combo is one of each of these, and they have to appear in the same sentence. Well, these are in the same sentence, and so are 6 and 29. I'll go with the 6 and 29 because there's no decimal in that. Might be a little bit easier. Okay, 6 minutes, 29 inches. Okay, so let's get these three things out of here. Okay. All right, so minutes. Minutes is X. Inches is Y. Okay, so Y. Y is going to be our 29, so 29. M, that's going to be our negative 0.5. Times our X, which is going to be the 6. Okay, so we need to find that product and then add the B onto it. So I have 29. Okay, negative 0.5 times 6 is negative 3 last time I checked. Yep. Plus B. Put a 1 in front of that. Okay, so circle that. Okay, so that's negative 3, so we have to undo that by adding. So plus 3, and 29 plus 3 is 32. And then 1b. So 32 is my beginning, okay? All right, now I can write my equation. 32 plus negative 0.5x equals y. Okay, and then the last number in the problem is the replacement value, 0 inches. And that's going in for y. Okay. All right, so here's y. Replace that with 0. So 32 plus negative 0.5x equals 0. Okay. All right, so here's my x. I'm going to need to circle it because it has a coefficient. Okay, 32, let's get rid of that. So minus 32. And negative 0.5x equals negative 32. And then divide. And that is going to be 64. Okay, so 64 minutes, a little over an hour. Okay, let's go to number 5. Again, I'll come back to number 3, but not right now. A skate park charges a membership plus a monthly charge. After 4 months, a member will have paid a total of $65. After skating for 8 months, the same member will have paid $85. How much total money would this member have to pay for 1 year? That means 12 months. Okay, because it's a monthly charge, we'll go 1 year. All right, so I want to find the money and the months. So the time unit is the X, and then Y would be the money. So per, dollars per month. Does it tell you the dollars per month? No, but I know there is one because I know that every month costs the same amount for everybody. Okay. So Y minus Y, X minus X. And away we go. Okay, so the Y is the money. So what do we have for money? Well, we got $65 and $85. So 65 minus 85. What do I have for the months? Well, I've got 4 minus 8. And that's going to be negative 20 over negative 4. And then divide those two, you end up with 5, positive 5. That's right, okay, because the money that we're keeping track of is going up, okay. That's pretty cheap, cost per month. Okay, whatever. All right, now it's time to graphically represent this. So, XY plus MXY. Okay, so I know the M is 5. And since I didn't even have $5 in the problem, I don't know where the money started, but there was a membership cost, so I know that I'm going to need to figure that out. Okay. So if I don't know the beginning amount before the rate of change, I have my y equals m dot x plus b formula. So y equals m dot x plus b. Okay, and we're going to need a combo on a story problem to use that. Remember, they have to appear in the same sentence. So 4 months and $65. That'll work. Okay, so I know that the months is X and the money is Y. Okay, so Y's out, 65's in. Okay. M's out and the 5's in. X is out and the 4's in. Okay, so I have 65. 5 times 4 is 20 plus B. Put a 1 in front and block that off. So we got 20, so we minus 20. Minus 20. 65 minus 20 is 45. And we can replace the 1, so we have 45. Okay. All right, so now it's time to write our equation. 45 plus 5x equals y. Okay, replacement value is 12 months. And months is X, so we'll be putting it in for X this time, not Y, because it's going in for X. So 45 plus 5, and then we're going to put 12 in, equals Y. Okay. So 45 plus 5, that's going to be 105, okay? So 105 equals y. Again, the y had nothing with it, so I'm able to just plug that into my calculator. So it's $105. All right, now let's go back and take a look at number 3, and I'm going to introduce you to how I set up 3-unit problems. Now this problem is pretty academic, and it can be easily solved without making all this stuff. It's just showing you how it works with an easy problem. Okay, because they're not always as simple. For Halloween, Mike is buying Snickers and Reese's. He has budgeted $25 for this purchase. Snickers bags cost $2.99 each, while Reese's bags cost $3.29 each. If Mike decides he wants 5 Snickers bags, how many Reese's could he purchase? Now, I know this is pretty easy. You know that he bought 5 Snickers bags and they cost $2.99, so you can multiply those. Subtract that from 25 and then divide by 329. Okay, I get that. It's easy. But the way I like to set up 3 units in algebra, because this has 3 units. We have the Reese's for my answer, but Snickers bags is another unit, totally different, and then money. So I can't making this, so I'm not going to be going with this route, okay? I need to kind of switch gears if I want to use an algebra way to solve the problem. In 3 units, I make kind of a tic-tac-toe box here. And here's how I set up the labels. I put how many units, single, and then total. Okay, now there's 3 units. Snickers, money, and Reese's. What are the 2 units that kind of go together? The product you're buying. Snickers and Reese's. So you want to put those right here. I didn't put anything here because they change from problem to problem. So Snickers and Reese's. And then we put together. Okay. Now with the money, that we also had money. All you do is put a $sign here above single and above total. Okay, so let's analyze each row here. The goal is to get to the bottom and have an equation that I can use. Okay, now let's talk about this. How many units? This means non-money. This row has nothing to do with money. Well, the only value that has nothing to do with money is the Snickers. Okay, so 5 Snickers bags. All right. And I don't know how many Reese's bags, so we're going to call that X. And then together, I'm not going to worry about that right now, okay? Because I don't even know how much that is. Okay, now the cost for a single. Well, how much does Snickers cost? $2.99. How much does Reese's cost? $3.29. And then this row, this button middle box, you never worry about. Sometimes you're going to put something here, but not here. Okay, now, and also anytime I put a number down, I like to cross it out. So I've used that 5, I've used these 2. And this $25 is the money total that I pay altogether. Okay. Okay, so what I do is I say, okay, what do I have to do to get to $25? Well, I'm buying Snickers. I'm buying 5 of them for $2.99 a piece. So I need to multiply 5 times $2.99 to find out the money total I paid for Snickers, and that's $14.95, 14.95. Now, I didn't know how many units of Snickers I bought, but I know they cost $3.29 each, so I can write the expression 3.29x. Okay? And then I can write the equation from the bottom, okay? 14.95 plus 3.29x equals 25. Okay, so we put a circle around that, and we have to undo the 14.95. So 3.29x. And I take 25 minus 14.95. And that's going to be 10.05. So I divide by 329. And I hope I get a decent answer. So divide those two. And I get 3.05, but that's okay because you can just afford 3 of them. You'll have money left over, is what I'm saying on that one. Okay, and that's how you do 3 units, okay? Pretty much another thing, I didn't really like how I went about this problem. I would fill in your money total together first, okay? Because they always kind of need to give you that, okay? And this is for non-money values. And you need these 2 filled in, but maybe not that one necessarily, okay? And then the money single, you never fill that in, then you just kind of multiply down the line.